Okay, well, welcome everybody. And yeah, Bob, you were just talking about some of the things going on in Florida, so we'll jump back into that. So you're saying battery technology, you're hitting a lot, but they're also trying to get rid of net zero metering in
Yeah,
Florida.
there's a bill in the state Congress to eliminate net zeroing.
Yeah. Do you think it's
And
going to go anywhere?
Well, it depends upon how much Duke Energy has paid the people. I mean, they paid Illinois $500,000, and what was it, California? The governor got how much?
Well, in Ohio, yeah, they paid, First Energy actually was convicted of paying $63 million to the Speaker of the House here in Florida and his group. And they're actually in the process of being tried in federal court. But they were able to get, I think it amounted to about a $2 billion subsidy through the legislation. So it was a good investment, so, yeah.
But how does an installer today work in a state like Florida if they go to no net zeroing?
Okay,
Well,
so we in Tennessee, TVA, to my surprise, doesn't have net metering. So what I tell people, we've got two basic choices. We can offset about 25% of your bill with a small system, and typically you would consume that almost directly. The other option is we can offset about 75% of your bill, but that does add batteries and increases the cost about 50%. But that way you get a benefit of, if the power grid goes down, then you have backup for your major systems. And to my surprise, we're getting a number of people fighting in TVA land for that.
Yeah, I think Tennessee has that added problem of, your electricity is relatively inexpensive, which is not a problem, but it is a problem if you're selling solar, because the more expensive the grid electricity is, the better option it is to those people selling an alternative.
Correct. Yeah, they get their power about 11 cents a kilowatt hour.
Yeah.
No, it's more expensive than that in Florida, I can tell you that.
Yeah. Yeah, I think you're going to see a lot of self-consumption systems out there, for grid reliability, but also as the grid operators make it more difficult to connect in. It just makes it pushes them towards self-reliance, self-consumption systems. They're already moving towards batteries because of grid reliability issues. The economics are starting to come into play where battery systems are becoming practical. And now you just start doing time of day, load shifting, peak shaving, all of those other good things you can do with batteries. So I think, as we get smarter, we'll find that we need the grid less and less. They need to come up with a reason why, besides just the generation of electricity, we should connect to them. That's kind of their challenge in the next few decades, is give us services we can't get independently, and give us a reason to sign up, like Disney Plus, give me Disney Plus if I sign up to the grid. Who knows what it is, but they're going to come up with some reason why we don't go totally islanded, especially if battery systems become super inexpensive.
Okay, but right now, my last house, I had an 11 kilowatt natural gas generator, and it was cost me $6,000, and I could become grid independent.
Sure.
At that point with solar.
Yeah, I think that's going to be a very practical thing. We've seen standalone systems have not been cost effective and therefore are only really installed when the grid is not available. But if the grid comparatively gets more and more expensive or more and more difficult, I think you will see a certain percentage of the people opting for standalone, islanded systems. I think Don, isn't your system an islanded system? You
It
stand
is.
alone?
Yep.
And,
Which is-
why did you choose that option?
I didn't want the cost of running the telephone poles from where the end of the line was out here was tens of thousands of dollars, and I assumed would make my own electricity and not pay for the poles and have them sitting running through the middle of the front yard.
Yeah. Well, you mentioned Florida being an issue. Let me jump into some of the news here. California is doing their share. It's interesting to me that California has always been sort of the bastion of solar as far as regulatory. But the California Public Utilities Commission recently ruled that they were going to put in a $57 per month grid access charge on those folks using solar. So that basically is the highest in the country for grid access. And when Nevada did something similar, their installs dropped 47% that first year when they put a very high access charge. The Nevada legislature then canceled that, and backtracked and things recovered. But there's protests going on. It's not passed yet. There's supposed to be public input. There's getting a lot of pushback on it. We'll see. I was wondering, who are these people on the Public Utility Commission who would come up with that kind of overreaction? Because they've been very liberal in access to the grid.
But Jay, don't they have a captive audience? I mean, because they've required solar to go forward in new houses, they require you to have solar. Now they're requiring you to pay.
Yeah. Well, these are all 5 of these guys on that commission, men and women, are Democratic appointees. 3 of them were from Newsom, 2 of them from Jerry Brown. And you would think in this world of liberal versus conservative, that they would be supportive of solar. So I don't know, maybe the utilities made a very compelling argument. That seems to me, as Don, as you're pointing out, if everybody's got to have solar and I'm a utility and you're giving me no opportunity to recoup my costs, I got to recoup them somehow, and what's that going to mean? So there may be legitimate reasons for it. I don't know. So it seems $57 is too high. $8 is probably too low, which is where they were. So who knows what the right number is. My guess is the utility went in with a high number, figuring they'd have to cut it somewhere in the middle, and they got all they wanted. So it's like the dog that caught the car, it's they're gonna have to deal with that. So
what's going to be existing with the grid in 20 years from now?
Well, I think the grid in 20 years from now is going to look very, very different from the grid that we have today. And we're already seeing it, it used to be a very vertically integrated system. Right. The same company that generated the power, transmitted the power, and distributed the power. Right. Now we're starting to see that break down into 3 different companies. Some of them are still wholly owned, but they're breaking them into divisions. So we'll probably see companies that specialize in high power transmission lines. I'm sure we already see that. There's a lot of government investment in that. So that would be sort of like high bandwidth fiber backbone systems, but now we're doing that with electric. Then you've got generating, whether it's customer owned generation or company owned generation that they sell their product, like not feed-in tariffs, but power purchase agreements with utilities. Or then you've got the distribution company, which I think will look like your normal utility. And they'll just charge for the distribution, for the connection to the grid. And
well, that's what's going on in Illinois. In Illinois, Edison does not want to buy electricity anymore from third parties.
Yeah, well, they probably have their own, their own capacity, but a lot of that is wearing out, and a lot of it is non-competitive with customer-owned systems. So yeah, they may not want to buy from third party, and to be fair to the utility, if I'm a utility and I've already got generating facilities that will meet 90% of my daily demand, and now the state legislature says, oh, by the way, anyone who wants to sell you power, you got to pay retail for it. Well, I don't like that. You know, I'm gonna react against that. That changes my model for my business. So, you know, I'm gonna have to deal with that. Now, they can react against it, but too bad, so sad. That's the reality of the future that they're gonna have to deal with. Not necessarily buying at retail, but the fact that their generating plants will be devalued because there are cheaper alternatives.
Well,
So,
I see a possibility they won't be in existence, even if they go through distribution, that even if you go into people getting together, going solar for a community.
But don't you think there's always going to be some people who don't adopt it? I mean, you know, there's a certain number of people who just aren't going to, you know, go forward.
yeah, I think they'll be in existence, but in a diminished capacity. I don't
Yeah.
think they will be the be all and the end all. The monopolistic world that they've lived in for the last 100 years will change. And if they don't adapt to that, yeah, some of them may go bankrupt. Some of them will be bought out or consolidated. Who knows how that will out. It's sort of like when Ma Bell transitioned, you know, in the late 80s. And the Bell system still exists in some form or fashion, you know, but not to the extent that they used to. I mean, now there are a lot of other players, a lot of other options. So,
But I see
I
that
suspect-
apples and oranges there. That's not the same thing.
well, I don't know, not the same thing, but analogies are always imperfect. I think we're going to see a transition in our utility grid to the same extent we saw a transition in our telecommunications system.
I see
How that
a
manifests, I don't know.
I see battle lines being drawn across the states right now in all different ways. And what's going to happen is that in the end, I'll just put my fusion reactor in my backyard and I'll be done with it.
Right, with your DeLorean, and you put some
Mhm.
banana peels in it and you'll run your
Yeah.
house, right?
Do you think
Um,
that some of the California stuff is that the public utilities are, if they are, especially if they're legally obligated to provide power to places that are built up in forests where they shouldn't be, so that the forest fire risk is high, somebody's got to pay for that. And, you know, someday if we all get taxed in the Midwest for all the people along the coastline that have their mansions that are getting flooded by global warming, sea rise, I don't think we'll like it either.
Yeah, I suspect what you're dealing with in California is the fact that they were the early adopters and they're going through a lot of the trauma that the rest of us will face, you know, as these systems transition. So that would be my guess, is that it's probably an overreaction, but it's an overreaction to a very real issue. So how they come down on that, I don't know. You're already seeing that the government is saying, all right, guys, now when you build a new building, not only do you have to put solar on it, but you have to make it battery ready. Well, they're already looking at buildings as independent islanded things, you know, that could be independent of the grid if need be. So that government is already anticipating that, where the Public Utility Commission, I think, has a different agenda. They're there to protect and serve the utilities, you know? So how do you keep that sector of the market functioning? So you got conflicting roles, conflicting motivations going on, and it's a mess, you know, which pretty much defines California, I suspect, but it's a mess.
So does coal generated electricity work well underwater?
Oh, well, California, I don't think has a lot of coal going on at the moment either. Yeah, I think coal, well, we've talked about it before. Coal and nuclear are antiquated technologies that are on the way out, largely due to they are non-competitive economically with natural gas, wind, and solar. Now the challenge is, how do you use intermittent resources like wind and solar to service that need? And battery technology is stepping in there and saying, okay, we can be part of that solution. Can they be the entire solution? I don't know. But natural gas is just stored sunlight. I mean, a battery is stored sunlight. Coal is stored sunlight. So, we're in a transition. And
I'd say I've got 2 weeks of recent history of weather that suggests that it's going to take more than batteries
yes.
to keep the grid going in certain times of the year.
Yeah. And of course, our solar panels are under a foot of snow right now. And I
Yeah.
just haven't felt like going out and cleaning them off. And if I did,
I just got in from that.
I'd get maybe 5 kilowatt hours of sunshine. So, it's not worth the effort. So, well, let me jump on to some other technologies. I saw, speaking of batteries, zinc batteries. I hadn't heard of zinc batteries. Maybe some of you guys had, but there's a large scale test going on with zinc batteries. And they're looking at zinc as 3 times the energy and 3 times the life of lead acid batteries. Cost is about the same as a lead acid battery, has a wider temperature range than lithium, and is 100% recyclable. So I don't know, sounds like a thing, another alternative. So we're moving towards additional technologies there. There was a couple of innovations here in Seraphim, which is a manufacturer, just announced they're marketing a 670 watt solar panel.
Same size?
I suspect it's pretty big, but it's 21.5% efficient. So that's pretty good. It is half cut cells, PERC, which is the passive emitter, something or other, the reflective coating on the back of the cells. So, it's the boom boxes keep getting bigger. These solar panels at 670 watts, pretty huge. Recycling, there was another news in recycling. The company, let me see, Recycle Solar is starting to locate in all of the Solaris solar panel manufacturing sites. So they're kind of doing a cradle to grave kind of thing. You can buy the panels from us, you can bring them back here to recycle. I found it interesting. They're basically saying 140,000 solar panels are installed each day in the US. And they're projecting that there may be as much as 1.2 million tons of solar waste by 2030 that will have to be dealt with. But to put that in perspective, McDonald's generates 1.5 million tons of waste every year. So, let's not get crazy about it. It is something that we have to deal with, but there's a lot of trash we've got to deal with, and solar is just one of them. But they're putting some energy into the recycling of solar panels. So we'll see how that works. I think it's going to get more difficult because, as we'll see in some of the other discussion I've got, there are a lot of different technologies that are emerging in solar panels. And
Hey, Jay,
yeah,
I just looked, that's an ultra large panel. It's 132 cells. So it's really misleading. It's really no more efficient than the standard 430 watt cells or the 380 watt cells we're putting on houses right now. It's
Right.
just that it's a super large format.
yeah, I understand that. I mean, 21.5 is pretty good. Most panels are going to be around 20% efficient, but that's not the game changer. It's just that they're getting bigger and bigger. It's definitely a 2-person panel. My
Yes.
guess is, do they have the dimensions on that you looked at? Because it's going to be hard to carry around.
Will they fit on a standard rack?
Well, I think anything will fit on a standard rack
You get to measure it larger?
if it's robust enough. Yeah, you just spread the rails further apart, So the issue
Yeah,
we run
they
into.
don't have well, let me see here if they got it. They might have it. I'll look.
Okay. Yeah, and the other thing in the news, the Department of Energy has just announced a few renewable energy things. One is they're offering the largest offshore wind lease in history, which offshore wind has not been a thing until recently, and now it seems that it's getting high priority.
Martha's Vineyard?
Yeah, probably not. It's probably off the coast of South Carolina or something, you know. It's where the poor people live. That's where we put this stuff.
Exactly.
Yeah. And there's going to be a big transmission line build out. That was part of the infrastructure bill, I know, because that was in that. So they're looking at that. And then they're got a rural focus for renewable. And this is where I think I tend to sort of fall on the side of the political spectrum with Don, where these are, they're focused on creating what they call industry clusters with a high focus on job training. It's like these industry empowerment zone kind of things, but for
That's what I was gonna say.
renewable. And I think they're well-meaning, ineffectual government programs. At least that's been my observation in the past. I hope I'm proved wrong, but they seem to throw a lot of money into people coming in and telling you why you should want solar and trying to train people who have not the disposition nor the skills to become solar people, when really who knows what they should be, you know. But you can't take a coal miner and make him a solar installer just because he's in energy. He has to have some motivation, some reason to want to go into solar. You know, so who knows? I don't know. I'm hoping it'll work, but I wouldn't hold my breath. So.
Jay, are they encouraging them to be installers, to like install up hollers or something? Or are they encouraging, are they trying to make like a plant or something where they're going to make solar panels or make batteries?
My guess is that's questions that are going to be the subject of meetings that will take the next 3 years. And at the end of the 4-year period, when the money runs out, they will announce what they intended to do.
So they've got money. Now they have to figure out what they want to do with it or what it might be used for.
Right, yeah. And some programs will be good, no doubt. Some programs will be a complete waste of time. But some of my jaundice on this is I was involved with the statewide broadband initiative to bring broadband to rural areas. And every time I went to these meetings, it was like, here's our new executive director and here are all of our plans that we're going to do. And it's like, okay, for the last 3 years, I've been meeting a new executive director at every meeting, and you still don't know what you're going to do. And still, I don't have broadband. So when are you going to do something? You know, when are you going to like actually address the problem? And
I believe that we should look into turning coal into solar panels.
yeah, they'd be kind of, though they're black, you know, they'd be kind of looking nice. I think graphite panels, why not? All right, so that's the latest news I've got there. Does anybody else have any issue before I jump in? Yeah, Bill, you've got something? You're on mute there.
Yeah, I just wanted to show this container again. Remember I showed a container with solar on the roof?
Yeah,
Is that okay to do now?
sure, yeah, go for it. Just
Okay.
share the screen.
Let me share. So I woke up with a crazy idea the other morning of making this a 2-axis tracker. And that rod represents the position of the sun in a summer day. That is, it's 7 degrees from being totally vertical. And let me make this happen. Here, 1 second. And I actually have a huge bearing that would presumably bear the weight of this container, which is 5,000 pounds. And I think this is a pretty bizarre idea, right? And you know, if somebody expressed interest in it, I might pull it off, but
You're gonna actually rotate the container like a lazy
that's right. I have
Susan?
about a 4-foot diameter deep groove bearing that I think would bear the weight of the container. And anyway, I just thought I'd throw that out for grins.
This about looks like a half of a box car, so maybe roundhouse technology.
Who's that?
That's Jay Clem.
I'm being
No,
totally
who's-
serious.
Who's roundhouse technology?
Oh, those for locomotives and railroads in 100 years
Yeah.
ago?
Yeah, they turn them around. Yeah.
Yeah, they had a big
Yeah.
thing that would rotate them on, yeah.
Well, but part of this, as I recall, you were saying, okay, this could be a first responder emergency kind of thing. You bring it in, you haul it in at a disaster site and set up, you've got power, you've got, food or water or whatever inside the container. And now you've got a power generating station. And I don't know how practical the spinning thing is, but certainly the tracking, setting them at the optimal angle is
Right.
certainly.
Actually, you may have missed the point. The motion on the other scenario is east to west every day. It's not to adjust for the season.
Oh, okay. So, well, yeah, if it's a temporary thing, you just park it at whatever angle you want it. You don't have to spin it unless it's there all year long,
That's true. Yeah.
Yeah, so I see you're doing an east-west tracking system there with the flip things. So at noon, they'd be lying flat, and then you just orient them west in the afternoon.
No, well, in the first scenario, they'd be flat. And
Yeah.
with the second scenario, which is a 2-axis tracker, they'll be where they need to be, facing the sun.
Okay. Yeah, I think, well, thanks for sharing that. Anybody else have anything they want to add to the group here? Well, oh yeah, Bob.
Pull me through the math on how to become independent. If I have a 10 kilowatt system putting out 13,000 kilowatt hours per year, and I'm pulling 7,000 kilowatt hours to maintain the house, how much battery do I have to become totally independent?
Well, again, that's going to depend on your daily load, how many days of autonomy are you connected? Well, if you're
7,000 kilowatt.
7,000, yeah. Okay, well, the process for calculating your battery bank is to take your daily load, divide it by the voltage of your system, then divide it by the depth of discharge. So if you've got a depth of discharge of 100% with a lithium ion, for instance, which is never quite 100, you can ignore that step. But if you've got lead acid batteries, then obviously you can't do the full 100%. You're probably going to go closer to 50%. And then you divide that, or you multiply that times the days of autonomy. How many days do you want to go if there is no power, coming from the sun? So you've got days like right now where everything's covered in snow. How many days do you need to go? And then you divide that by the inverter's efficiency. So those would be the steps. My guess is in a totally independent system, the first step you want to go is to really maximize your efficiencies. Bring your load down as far as possible. So that's going to be your first step. With new lithium ion batteries, they're starting to get relatively inexpensive. So maybe Bob, you could, or Don, what is your situation there? Because you're not exactly, frontiersman here with, living.
Oh, no. No, there's, yeah.
Comfortable home, right?
We started frontiersman, and then the marital compromises turned us into a very nice place.
Yeah. So what is your daily load roughly?
Let me see. Actually, I've got this system. I might see if I can pull it up right now and just check. Consumption charging. Right now, I'll be honest, 90% of it, because I've got geothermal, 90% of it's running the geothermal.
For your heating, right?
Yeah. I'd have to go back and check. It's not the average 30. During the normal time, only one person lives here. And he, my father-in-law, watches TV and, has the cats here. So he's not doing a whole lot with electricity, to be honest. I would have to, let's see if I can pull it up. It'll give me monthly. Hold on. See if I can get the last year's up. The load. I don't know if that's a year or the
While
kilowatt
he's
hours.
looking,
Mhm.
Well, he's looking, one thing that makes that equation noticeably more challenging for most people is there's a significant difference between how much solar you generate in the wintertime versus the spring or summer. And typically highest loads are in the winter. So probably you want to look at your loads, not on an annual basis, but your loads in the wintertime
Mhm.
versus your generation in the wintertime and try to match that. And so that's where it tends to be a lot more expensive to go off grid because you have to design for wintertime when the days are short and more storage when you have more clouds and when your HVAC needs are kind of peaking out.
Yeah, in doing that design, it's basically referred to as like the critical month, where you're dividing your average insulation for that month by your load demand for that month. And you find out which month is worst. And then you design the system as if that was the annual average. I mean, you could even extend that to the worst day, but that's a little crazy. So yeah, it's critical month. And as you say, when I've done some of those, it usually ends up being February that becomes the worst month. Sometimes December, but it depends. So they're expensive, but what size battery do you have there, Don?
It's 130 something total, but it's it's lithium ion carbon. Let's see what they call it. It is carbon mat or something.
137 kilowatt hour?
Yeah, so but only half of it's usable. So I always go by 66 is what I assume I have for usable amount of energy for the day.
So you're going 50% depth of discharge even on a lithium ion battery?
No, it's not lithium ion. It's
Lead acid?
it's like a lead acid, but it's not. They call it something else. It's like carbon mat or something like that.
Okay.
I'm trying to let's see if I can find the name. It's a partial carbon charge or partial charge carbon is what they call it, but it's the same kind of thing as a lead acid. So yeah, you've got a 50% depth of discharge. And actually I'll be honest, the inverter reset it to 0 to recalibrate the whole thing the other day. And when I talked to one of the people at the helpline, they said, well, maybe you're going up and down too much or too frequently or not fully charging it back up all the way. They were suggesting it was causing a problem because during the winter, it might go up to 80%, then go back down, then go back up and back down. He was saying that was likely going to, over the long term, going to cause a problem with the battery.
That you weren't fully charging it?
Yes.
Uh,
Does that sound right? I mean,
Well, I know that used to be a problem with the old NiCad batteries,
mhm.
where they developed a memory. It seems to me that it might increase sulfation. I don't
He thought
know.
it was sulfation. It wasn't so much, I don't think the memory, but he thought that it could start increasing the sulfation.
That seems reasonable.
Okay.
That's just a vague notion guess. I know that if you go too deep in depth of discharge, it'll increase sulfation.
Mhm.
So if you don't fully charge it, you could probably overcome that by equalizing it periodically. But you're not connected to the grid, so that might be a problem, which is basically overcharging your battery.
That's what the generator's for.
Oh yeah, well, you could do that. And
Yeah.
then, they're usually set up, your charge controller's usually set up to do equalization at once a month or so.
Mhm.
Well, maybe you do it every 2 weeks, just to keep that maintenance going because you're not fully, or use your generator to fully charge your battery, if you're not going all the way.
Yeah, that's what I have been doing for the days where I have an issue.
Yeah.
So,
Okay.
what I'm reading for the load is all over the map.
But it's not the 30 kilowatt hours per day that's standard suburban.
Actually, in the wintertime, it's more because of the heat.
Yeah.
If I go to the summer, it's like I'm looking at 18. Well, if I go back to October before it got cold, it's like 19, 18. Obviously, it's best when there's no heating or air running.
So Bob, basically go out and buy yourself a Ford Lightning. That's 98 kilowatt hours and you're all set.
Or you can get the nice one for 130 kilowatt hours.
Yeah. It comes with the free 80 amp charger. So-
Well, it comes with a free truck if you want to buy the batteries.
That's right. Uh-huh. Yeah,
So what
we
do we
did that.
get? You get 4 days out of it?
You get, what, 4 days? Yeah, 4 days
Yeah.
on the big one, for sure. I mean, that's no conservation. That's a standard residential
Is
load.
that enough to get me off the grid with a 10 kilowatt system?
It would, I would think, but you may have to, yeah, I don't see that that would be a problem if you're off grid, because it does say it requires a 100 amp dedicated circuit, for the charging station. But if you're not on the grid, your system should have 100 amps floating around. When you take your 200 amp service away from the grid, you should have that kind of capacity.
Well,
So,
I think to answer that I mean, you can't really answer that question until you really know your loads. That's like saying, how far can I go with 20 gallons of gasoline?
yeah,
And, a 10 kilowatt system is like 20 gallons of gasoline. If you have a Ford Prius, or if you have a Toyota Prius, you can probably go 1,200 miles. But if you have a Suburban, you'll be lucky to go 400 miles. And it all comes down to your load.
you mean when you're using it and how you're using the load?
Yes, and
Oh,
how,
what he was
what's your
saying,
total? He's saying,
said
can
you
you
have a-
go off grid with a 10 kilowatt system? Without knowing his load, you can't answer that.
yeah, he said he was doing 7 kW a day.
Yes,
Yeah.
yes.
So 7 kW a day with a 10 kilowatt system, I would assume
Oh, yeah,
you're
that's,
probably good. So,
okay, I'm sorry, I missed that.
yeah. All right, yeah, in fact, 10 kW is probably overbuilding for that. I mean, 10 kW should handle a 30 kilowatt a day load pretty easily, depending on your sunshine and your orientation. So, okay, let me jump into some of the building integrated, just because I did some research on this, so I'll share that with you. Building integrated solar is one of those things I keep hearing about forever and ever, but never truly it comes to pass, or it's a thing, at least in my life. I do believe it's a thing. I just don't run into it very much. And basically the difference between building integrated PV and regular PV is that it's built into the structure as opposed to added on later. And building integrated usually takes place in 3 different locations: the roof, the facade, and externally integrated devices. I guess they mean awnings, balcony barriers, or solar carports maybe. I don't know if that's included. They're usually, with the facades, talking about windows, roof, glass, siding, skylights. And I found some interesting information. They're really talking about the 4 generations of building integrated solar. And the first generation was crystalline technology, monocrystalline, polycrystalline, being integrated into devices. That was sort of generation 1. And that might look like solar shingles, for instance, although that would have been a thin film, but maybe solar skylights. I've seen some of those where it's just built into it. Second generation was transparent or semi-transparent thin film, where those begin to be part of the awnings or even windows in some buildings. The one that I find fascinating is the third generation, which is kind of where we're in at the moment. And here they're referring to perovskite, which is a transparent technology. Some of the problems with perovskite is they tend to be short-lived. There's some robustness issues there that they're addressing, and they have been seen to leach lead into the environment. So they're dealing with that. So perovskite shows promise in that it's a very efficient technology. It's inexpensive, but there are some pretty major hurdles to overcome there. But it is transparent, multicolored. But then they get into some I hadn't heard of, which was DSSC panels. Has anyone ever heard they're dye sensitized solar cells? Have anyone heard of these things on the call? They're basically the photon is absorbed into this and then passed to a conductive area through the die within the cell. So it doesn't sound like it's a 2-layer transmission process. It sounds like it uses dyes as a conductive process, but I just had never seen DSCC. Then there were quantum dot solar cells, which I have heard about. Essentially, these are cells that use very, very small dots of silicon within the panel to generate, and these can absorb over a wider spectrum, like the multi-junction PV. So a wider area of the electromagnetic spectrum can be harvested into the infrared, the ultraviolet. They are competitive now, around 16% efficiency. Then there was another one I'd never heard of, copper, zinc, tin sulfide cells, which is another thing. And apparently these are also a thin film technology, but they are non-toxic, environmental friendly, recyclable. And then of course, organic solar cells. Hadn't seen those as a thing, but they're talking about using organic material rather than silicon in the cells. Not quite sure. I mean, they say they're environmentally friendly, but I didn't find references to what exactly that means. Do they decompose, when they're thrown away or whatever? I'm not quite sure how they're organically friendly. Silicon, being sand, is not exactly the end of the universe either. And PV glazing, I guess, is a thing where the gap between two glass panes is filled with organic PV cells, and that becomes a thing. So there's a lot of new technology, and it sort of brought to my mind the whole thing with recycling. That's going to make things more difficult when everything's made of something different. Then the idea of creating some sort of mass recycling center becomes more difficult. It doesn't preclude it, but it's now you've got cardboard, glass, and aluminum instead of just aluminum cans or whatever. Some of the advantages of integrated solar is it looks nice, aesthetics. Can in fact save labor and materials if you're using the materials of the panels in lieu of having to buy something else. Disadvantage is it's typically very high cost and less efficient. So I just thought it was worthwhile touching on integrated solar PV, because we always hear there's monocrystalline, polycrystalline, thin film technologies, and building integrated as a thing, or there's ground mounted, roof mounted, building integrated. They did mention the 4th generation in these things, which they're looking at multi-junction PV as essentially the 4th generation of solar cells. And if you've been through my class, we talk about that, where that becomes a very efficient methodology, but also has the promise of harvesting well outside the visible light spectrum. So at that point, you begin to see the harvesting of ultraviolet, infrared, but also cosmic radiation. So now you get into a 24/7 kind of harvesting thing on solar, as opposed to just the sun is shining, the wind is blowing. Well, at that point, battery technology becomes a less of an issue. Probably you won't get the same efficiencies at night, I would assume, as you would during the day, but probably don't need as much electricity at night either. So anyway, I just found those things interesting. Has anyone ever worked on a PV, building integrated PV system? Did Bob, you had something to share there before I posed the question?
Yeah, I went down a road here where people talked about replacing roofs in the Chicago area. And I came to the point that everybody's got in a 25-year period in Chicago, got to replace their roof. Whether they do it within the first 3 years, or whether they do it at the 20th year. And I checked with a friendly competitor, and he says, yeah, we're tearing down solar panels all the time, letting roofers go up there and change it, and then we put it back up again for a fee. And that's part of the business that's going on. So, and you can even talk about taking it down and putting it into the next house you buy.
Mhm.
Um,
Well, we talked about at one of the previous discussions about the secondary market of solar materials and how that's going to be a big thing. So I think what you're going to see, what was keying it in my mind was when we talked about the N-phase systems and how they've basically taken their microinverters now and broken them into 3 different families. So the M250s and the M215s have different capacities than the i7s, i6s, but that the i8 now has a 3rd capacity, which can be a batteryless, islanding, a backup where you can use your array during daylight hours without batteries. And it struck me that there will be people who say, you know what, I want to swap out all of my microinverters now with i8s because I want this new functionality. Well, you've got 15 years still on warranty. These microinverters are going to last a long time. Same things with solar panels, look, there's a newer one. It's better. It's more aesthetically pleasing or whatever. A lot of people have a lot more money than I do. So they're willing to swap these things out. So then you have a secondary market for this stuff, whether it's a domestic secondary market or it's for third world nations or whatever. I think that's something we're going to have to deal with as well. I mean, it's going to be a whole new thing.
What is your opinion on the GAF solar shingle, Jay?
I hate them.
Oh yeah,
I hate all things solar shingle. I just hate those
Because of how they look or for specific technical reasons.
for specific technical reasons. I don't care about the aesthetics of them. I don't care about the aesthetics of solar panels. I just think whenever you're integrating them into a roof, then there will be problems. And when you have to fix those problems, it is a difficult thing to fix. And those, I think specifically the ones you're mentioning, are 1.5 inches thick, right? Because they have to integrate electronic devices. They have to have the rapid shutdown devices built into them. So it's not just laying out flat shingles. It's going to have a visual impact on your roof as well. And I just think there are better ways to deal with the aesthetic issue than all of the problems solar shingles create. So most people look at solar shingles or things like the Tesla roof because of aesthetics. And I think that's something that can be better addressed with a different option, whether it's they have those little things you can adhere on them, almost like decals that mimic your shingles on a regular solar panel, like a transparency covering that is like camouflage. You can do that. That would strike me as a better option than integrating it into your roof.
Well, that was the question I was moving towards, that of how easy it is to remove solar panels when you have to replace the roof. But in a lifetime of 25 years with integrated shingles.
Yeah, you're going to have to pull them up.
High cost there.
Yeah, and most of those are going to be a thin film technology that do not have a 25-year life expectancy. So these shingles are not going to be as robust as a silicon panel. So I don't know. What do you think, Siggy? Do you like solar shingles?
well, I've looked at the product. The new GAF solar shingle, I think it's actually a monocrystalline panel, and it's nailed onto the roof, which is fast and easy. It still has about every, I think, 6 foot, it has a cable channel that, as you said, is about like 1.5 inches thick or so. So it's not completely flat shingle. It's interrupted with a vertical cable channel every 6 foot or so. Well, I always think about temperature, so I think I lose 10% in power right there because of the increased cell temperature.
Yeah, because there's no passive air cooling of those
Yeah.
because they lay right on the deck.
Mhm.
But I have not inquired yet and how much they are and all. They look decent.
Mhm.
Yeah, I don't know. Uh, GAF is a big company. If they warrant them for 25 years, then they can back it up. Then it might be worth looking at it.
Yep. Well, it's another skill set though, also bear in
Hmm.
mind. I mean, it's something that solar, is this going to be installed by roofers or is it going to be installed by solar installers? You know,
I think
because
they're training their roof
They're
crew,
shooting for roofers, yeah.
the
Yeah.
roofers.
That's the
And
market.
one thing I'm puzzled about, maybe you can help me out here. I don't understand how they get rapid shutdown in there because there's no way that a fire safety switch or anything fits in that channel. It's just MC4 connectors that connect to each other. So is there something that exempts building integrated from rapid shutdown?
well, I saw the issue of one of those and I thought it was the GF that the shingle itself was 1.5 inches thick. So the electronic device was integrated into the shingle, which kind of defeats the whole purpose of it
Yeah.
as far as I was concerned.
I don't exactly know how thick it is, but yeah, I saw the spec somewhere, a spec sheet online, but can't remember it now.
Yeah, I think building integrated, you know, the roof is the area that's of concern. If it's a facade on the building, that would not have to have rapid shutdown. It just has, if it's on the roof, you've got to deal with rapid shutdown so that the
I don't know
firefighters.
how they're doing it then. I don't know.
Well,
I don't,
actually, now that I say that, you'd have to have them shutting down at the source anyway, because even if it's on a wall, you don't want it generating power to a remote location.
yeah, it's yeah, I don't understand. I think there's something in the code where it says unless it's a listed system, but I'm not sure what that means. Like,
Yeah, there is the thing where you can get your entire system listed as compliant with rapid shutdown.
yeah,
But those, of course, would have electronic devices built into them.
yeah, okay.
to shut it off. But they talk about that each component has to be, you know, listed, or the entire system has to be listed as rapid shutdown, or else you must comply with the, you know, goes to within 80 volts.
80 volts within 30 seconds with, and
Do they have inverters up there on the roof with them, or is it
Sometimes, I mean, for rapid shutdown, if it's a microinverter system, yeah. But
Okay.
mostly now they're just power electronics that do the shut off at the roof instead of at the inverter.
well, wherever the inverter is where you're gonna have your rapid shutdown?
Yeah, unless you've got an electronic device that takes over that role at the panel. So typically now you've got sort of the 3 levels of shutdown at the panel. The microinverter where everything's done up there, including rapid shutdown. The power optimizer where you've got MPPT and rapid shutdown. And I don't remember, is arc fault up there too? I'm not sure. And then you've got just the electronic component that does the rapid shutdown. And each one of them is progressively less expensive for that piece of electronics. But I think it's what Tygo, I think, makes some of those just rapid shutdown
yes.
things
Mhm.
for various string inverters. But pretty much all occupied buildings now must have some electronic device attached to the panel, you know, to shut it down at the panel. That's kind of where we're at now. If it's a detached unoccupied building, not so much, although your inspector may require it. If it's a ground mounted system, then no, you don't have to worry about rapid shutdown. But
Yeah, there has been an argument about carports, but they still have to have rapid shutdown.
even if they're detached,
I think it's about if it's like human occupied or so, then I guess it needs to have rapid shutdown. The only time it's exempt from rapid shutdown if the structure has only one sole purpose, and that's carrying the solar module.
yeah.
But if you give it a second purpose, like a carport or a barn or some shading structure, then I think it has to have rapid shutdown.
Even our ground mounted that we let the goats sit underneath for shade.
No, I think that would be exempt.
Yeah, it's not human occupied in
Yeah,
any way.
yeah.
But it's got a secondary use. It's got that shade.
I know.
Yeah,
In
okay.
Tennessee,
I guess
it
you
doesn't-
mean maybe.
Yeah,
In
Dave.
Tennessee, it's any building. So basically, if it's a carport, not human occupied, a tractor barn, even a barn with no animals in it, if it's a structure, we have to follow rapid shutdown.
Yeah. Do you know if the same applies with setback rules on detached carports and detached garages? You know, the 3 foot on the sides and the peak and, because I've run into that before where the inspector has said, no, it's not required if it's a detached garage. You know, it doesn't have to have that 3 foot setback.
That might vary from jurisdiction to jurisdiction and.
Well, it
city.
also, yeah, it's part of the international fire code. And many
fire code,
states have not adopted the international fire code.
But
No,
But
like
see, that's
Florida.
where the fire code is up to local interpretation. Because if it's, some people interpret that to apply if it's a human occupied structure, or if it's possible that a human would be in there. But if it's not, they don't apply it. So we unfortunately have to kind of follow the individual inspector. And if he wants a 3 foot setback, we do that.
Yep. Yep, because the inspector's God. Just ask him. Right? Okey doke. Well, I think we're coming to the end of our time. Anybody have a 30-second?
Yeah, Jade, I have a quick question for you that's related to the course. Maybe you can look into that later, but the online course, it seems to be in chapter 2 in the lab quiz. There seems to be a glitch at the moment. So if student tries to forward or select the answer for the SunSpark module question, then they can't continue that quiz. I don't know. It's
Okay,
Does Jay
I'll
make
take a
him get the
look
right
at that.
answer?
Hmm?
Does Jay just make him get the right answer? They can't go forward?
They can't go forward. Yeah. I was running into some issues with that because Microsoft did an upgrade, and it really messed up the class while we were going. Because everybody was having computer problems. But let me check on that, labs. It may just be something needs to be reinstalled. I'll jump on that.
okay. All right. Thanks.
Okay, thank you. All right, well, thanks, everybody. We'll see you all next week. All right, take care.
Okay.
Bye.
Super.
Bye-bye.
Awesome.